All right, let me see if I got this. Paul, right? Paul and Zach and Jacob and Chad and Damien, was it? Damien and Wing and Timur. Close enough. I'm going to get there, don't worry. Let's see. And then Sterling and then Will and Clay and Jeremy. And then we have Martin, Oliver, and Xavier, Christine, and Travis. Get everybody? Okay, did I say anybody's name who didn't, like, if they want a different name, let me know. Let me know now, or I'll just call you that for the rest of the time. Did everyone get one of these little guys? Okay. Question number one. Question number one. Who has not taken a math class in at least 5 years? Pretty much everybody, right? Almost everybody. So what that means is you guys might be a little rusty on some of this stuff, right? That is okay. All right? This class is, we have a fair amount of stuff to cover in the class. In other words, we've got a pretty good amount of stuff to cover. But you probably have some point in your life seen this stuff before. Okay? Even if you didn't go to high school or got a GED or whatever, you probably have seen this stuff at some point before. It doesn't mean you remember it, right? So we will try to go. I'll put a lot of stuff on the board. If you'll notice, I'm actually taping the class. I will put the videos on YouTube, okay? And we will be doing a ton of practice in this class, okay? So all the stuff you see on the board, get it down. But then really, the only way you're really going to learn this stuff is to actually practice, practice, practice. Christian mentioned a little bit about me. I've been teaching for a long time now. I'm actually here at CJTF HOA. I'm now it's the J357 Deputy Director for Effects. They just did a huge. Anybody else in HOA here? Oh yeah, we did a whole like change of where everybody works and all that. So we're still trying to figure that part out. But anyway, as I mentioned earlier, when some of you guys were in here, we're all busy here. And that's the one thing I absolutely understand, that we are busy people. We've got full-time jobs. This is a secondary thing that we're doing right now. That's not to say it's not important. Okay? This is a college class. Who's taking this is their first college class ever? Anybody? Oh, good. OK, you all know about college classes, right? So my point is that I'll understand if you're busy. OK? I'm not going to assign too much homework. OK? For instance, this week there's a homework assignment due on Saturday. We'll talk about it and discuss all about that in a little bit. And there's actually 84 questions. Now, that sounds like a lot, right? OK, there's 84 questions. But over 7 days, everybody know what 84 divided by 7 is? First math question of the day? 12, right? That's 12 questions a day. And some of these questions are like, let me give you an example. Some of these questions are like 6 blank 3 replaced with either greater than or less than, right? So in this case, 6 is greater than, right? And we'll talk about the details if you forgot that stuff. OK? So that's like 1 out of 84. You're already done, right? So I mean, over the course of the semester, the number of problems will actually drop per week because they actually get a little bit harder. So they take a little bit longer. But there is no more than the website. Hopefully a lot of you guys signed up. I know a lot of you guys signed up for it. We'll talk about that in a minute. The website actually tells me approximately how long it should take you to do the homework. None of the assignments say that it should take you more than 2 hours over 7 days. OK? Now, some of you it may take 6 hours because you're rusty on some of this stuff. OK? But the point is that you have to be able to, I'm not going to give you too much homework, but it is going to be practice. And that's the only way you're going to really learn this stuff. OK? It's the only way you're really going to learn this stuff is by actually doing it. OK. You guys can call me Chris. Please do in here. We are not in the military in here as far as I'm concerned. Although, I will say that if I catch anybody cheating on tests and things, I'm going to put the hammer down on you as much as I can as far as the military goes. Because I hate cheating, and I know it's one of those things where you got to make sure that that's primary interest is not trying to get away with doing something in here that you shouldn't be like that. So as far as in here, I'm Chris. You guys, I'll call you by your first names unless you want me to call you something else, and we'll go from there. Classes are 3 hours long, right? That's kind of a long time to be thinking about math. Okay, so we'll take at least 2 breaks each class. All right, so we'll do it like an hour or so, and then we'll take a break, an hour or so, and take a break, and then be good. Dinner's a little tricky to get. Now that the Combat Cafe is open, it's a little easier to get over there and back pretty quickly, especially now that they're just like sandwiches over there. Line's pretty quick. If you do want to run all the way down to the regular galley and try to get food, well, that's up to you, but I might not wait for you to get back in some cases. About 10-minute breaks, 15 tops. Okay. Let's see. I handed out a little sheet here. Did anybody not get the sheet? Everybody's got it? All right, let's go over this real quickly. I'm not going to bore you with it all. I know you can read. The big details are, you should all know you're in math class, June 8th through July 28th. It's only 8 weeks. It's actually a pretty short amount of time to do a whole semester-long class. Okay, I mean, we crunch a lot of stuff into those 8 weeks, but it's all good. Let's see, that's me. You can call me Chris. If you do need to contact me, email is probably the easiest way. I check my email all the time, and you should be able to get in touch with me that way. And I'll be sending some stuff out on email as well. There's a website on here. The website will have all the videos, links, and any other information. Like I'll show you a couple little videos today, and I'll put those links on there if you want to relook at those. Office hours. On here I have office hours 1800 to 2000 on Thursdays. Anybody think they can't make those hours on Thursdays if you needed to come in for some extra help? Let me know now, or they're not going to get changed. You would not be able to make it? Is there a better time for you? Okay, I'll talk to you offline. I'll talk to you offline then. As Christian mentioned, the office hours are just for you to get extra help. Now, that's a good chance to, if you're having specific problems with homework assignments, come on in and we can work on them here. Unfortunately, because of the way the website works, there's only one computer we can have in here that's on the website at that time. So you might want to just print out questions or write down the numbers, and I'll bring them up on here if you have questions, and we'll get through that. Okay, but we'll plan on Thursdays 1800 to 2000. Okay, going back to the being busy part. So one of the things I have to do with my job is we have an operations and intel brief every Saturday that normally it goes from 16:30 to like 17:10. So I'll be rushing over here after that. Today it actually started at 1700, so I had to have somebody cover for me. Sometimes I may be a few minutes late. Give me a little bit of time. Maybe I'll try to send somebody over with some practice problems you can work on or something like that. But I promise I won't keep you after 2015. Unless there's some other emergency or something like that. Okay, that'll be my fault there. Let's see, the book. Hopefully you guys got the book. I had some emails with some of you guys. So the homeworks, as I already mentioned, are all going to be online. Okay, what that means is you have to sign up for the online system, which means that you have to have an online code. Hopefully most of you guys got the email I sent around about that. If you didn't, we should talk after class, and we can get you hooked up on that. The problem is if you bought the book from somebody else, you may not have the code, and it's kind of annoying. But unfortunately, it's the best way to do the best homework for you guys. And so I have to insist that you get the code. If you have some absolute reason you can't do that and can't get online or whatever, talk to me and we'll see if we can work something out. But I really would like you to do that because we're all trying to do it, and it makes the most sense to have everybody on the same page. Okay? Grades in here. This class has an exam that's given, the same exam is given to everybody in the world, or at least in UMUC Europe, who's taking this class. So that means we have to be prepared for the same exam that every other class is prepared for. Okay? Which means that we'll be doing a lot of work, and at the end I hope you're all prepared for the test. I think you will be. We're going to go over all the stuff that's necessary, and we're going to make it so that you are well prepared if you put the time into it. I'll mention that again in a second. Okay. On the back of this sheet is our little schedule. Okay? You'll see we have 7 homework assignments. They are all posted online right now. If you happen to be a math whiz, right, you can go do all the homework assignments right now, and then you won't have any more homework for the rest of the semester. I don't really care when you do the assignments. Knock them out whenever you want. But we will be covering work in the 2 days during Saturday, Sunday that will be due the following Saturday. Okay? So as far as work goes, homework goes, it's all right there, and it's already online, and you can look it all over. We have 1, 2, 3 regular exams. The first one is actually in about 2 weeks. Right? First exam. I have to give you guys exams because I need you to make sure you know how to do the problems. Okay? Some of the, like the science class I taught last semester, yeah, I gave them exams, but it wasn't, like they didn't have to do problem solving. You guys have to do like actual problem solving, which brings up another point. I will not hold this against you. How many people think that they hate math? Oh, come on, I won't hold it against you. OK, OK. My job here is to make you not think that you hate math. OK? Your job is to try as hard as you can to concentrate and to try to understand this stuff and to ask me as many questions as you can, either in class or in the tutoring sessions, about why you're not getting this stuff. Okay? As I said, you have seen almost all of this stuff before in other, in math classes that you took like, well, more than 5 years ago, I know, but you've seen a lot of it before. Okay? My job is to refresh your memory and make it so that you, even if you didn't know how to do it last time, you get that this time. But I really need you guys to put the effort in. And if you're not willing to put the effort in, my suggestion is drop the class. I mean, if you're not willing to put the time in to learn it, well, that's kind of not my fault anymore, right? If I have any faults, it's because I'm not explaining stuff right, and you guys will tell me. You'll go, I don't get that. You didn't explain it well. Fine, tell me that. I'm happy with that. We'll try to get it so that you do, I do explain it better. Okay? But the idea is it's a give and take, and you guys have to put the effort in. Okay? So think if that concerns you, that this is a class where you're not going to have to do much work, stand by, because you really have to put the time in. It's not going to, I mean, to say much work is you put as much work as you need to do to get the job done, right? Okay. So anyway, homework assignments on there, tests are on there. We do have a final, as I said, and I have no control over what's actually on the final, for what it's worth. Okay. I tell you what, I was going to show you the online homework, but what I'll do is I'll wait till the end until we get to a point where you actually know some stuff that I can show you. So I'll show you how to do some of the homework assignments. It's a little tricky online to get some of this stuff done. OK. All right, I've done enough talking. Any questions so far about the class or whatever? Christine?
On the June 15th Saturday, it says 5.6 and 1.3.
Yes.
What is that 1.3?
Oh, OK. So the sections here are in your book. Yeah. So like we're actually going to jump back to 1.3 in the book is actually about problem solving. Yeah. So it's just a little bit. We're going to do a little bit on general problem solving techniques. Okay. So that's what it is. OK. Yeah, these are the sections of the book if you want to go ahead and read the book. I mentioned to, I think it was Christine the other day in an email, that I would love it if you guys sat down and read the book. But it's hard to read math books sometimes, right? They're not the most. You got to really put your heart into it to keep yourself reading. I think it's difficult to read math books. Okay, that's why we have class, and that's why I'm going to be up here doing a lot of problems. If you can read the book and you want to read it, great. That actually probably will help you. But if you don't, I mean, I understand. You can take good notes, and you can watch the videos again and whatever. But it all, again, comes down to actually problem solving and paying attention and asking the questions when you have them. Other questions at this point? Oh, one other thing. Attendance. As I said, we're all busy. We've all got things. There's a couple people today who are out. If you have to miss a class, we're in the military. We got a lot of stuff to do. Sometimes we're on duty, whatever. If you have to miss a class, just email me and let me know. And we'll work out the details. Okay? If it happens to be a test day, we'll take the test different time, etc. Okay? If you get tired in class, because I am going to do a lot of talking and showing you stuff up here. If you get tired, same with most military things, stand up, go in the back, shake yourself out, go get a drink, whatever. If you need to go to the head, I don't even know where the nearest head is these days. They took away the porta potties. So that way? It's right around the corner that way? OK. If you need to go, just get up and go. Don't worry about bothering or raising your hand or whatever. Just go and do it. We're all adults here. OK? All right. Let's see. I think that's most of the preliminary stuff. Anybody have any other questions? OK. Let's get into some math. All right. And I guess I don't see many notebooks. I suggest maybe writing some of this stuff down. What we're going to do, if I can find it here, is I'm going to hand out some problem stuff, but you can't really take notes on them, and there's not really enough space to take notes on it. But I was going to say, if you have, yeah, some people are getting on notebooks. If you want to take notes, great. If you don't, maybe you can use a little blue sheet or whatever, and I've got some other scrap paper if you do want to take notes. OK, let's do a little bit of math. OK? And feel free to tell me you still hate math after today, too. I'm OK with that, but you can still hate math if you want. You just still have to learn it. OK, let's start with something easy. All right? Let's start with regular old numbers. OK? 1, 2, 3, 4, 5, 6, ... OK? These numbers, OK, are called natural numbers. These are the natural. And by the way, if you can't see the board or I don't write clearly enough, let me know. The natural numbers. Why are they the natural numbers? Because they're the way we naturally count. OK, pretty simple stuff. OK, 1, 2, 3, 4, 5, 6. Let's see. If I was to keep writing this, I'd go all the way over here. And like, what would be way over here? 100. Yeah, maybe 100. I don't know. 100, right? If I kept going and kept going, I could keep writing. What's the biggest number? The biggest number in the ever? Infinity. Infinity is not a number, actually. There is no biggest number. For what it's worth, infinity is kind of a concept. OK, we won't be talking about infinity in here. Don't worry. OK, don't worry about that. OK, this is relatively basic stuff when it comes down to it. These are called the natural numbers. OK, there's a number in there that we didn't talk about, 0, right? 1, 2, 3, ... These numbers are called whole numbers. Whole numbers. I'll use the little number symbol there. OK, whole numbers are the natural numbers with 0. OK, why don't we just include the natural number, the 0, in the natural numbers? Any ideas?
You don't count 0, 1, 2.
Because you don't count 0, 1, 2. That's part of it. Anybody? You guys remember Roman numerals? Like way back in the day, right? A clock, whatever. Roman numerals. So if you want to do like, if you want to count with Roman numerals, anybody remember what 0 is in Roman numerals? There isn't a 0, right? That's because way back then, they didn't have the concept of 0. This is the easiest one to do. It's easy to pick up 1 rock and look and go, that's 1. And it's easy to pick up 2 rocks and go, that's 2. And you can go, oh, I get 5 rocks together. Oh, that's 5, right? It's easy to name those things. How easy is it to pick up 0 rocks? Right? You can't do it, right? That concept is actually a pretty tough concept. Like overall, in the grand scheme of numbers, the idea of having nothing and calling it a number is actually a little strange. OK, it took thousands of years for people to figure out, hey, we should add this number in there. Right? It took them a long time to do that. OK, well, anyway, whole numbers. OK, there's one more set of numbers. What's missing from these if we're talking about numbers that aren't fractions? Still no fractions, no decimals. What numbers are missing? Negative numbers. OK, we have these things called the integers. OK, the integers, which is -1, -2. Well, I should go this way. I'll start with -3, -2, -1, 0, 1, 2, 3. OK, those are the integers. These are the 3 types of numbers that we're going to talk about that aren't fractions or what we call irrational numbers. OK, these are the 3 types. OK, so far, everybody with me? All right, so far so good. Maybe you remember something like this, a little number line. 1, 2, 3, -1, -2, -3. We're going to talk a little bit about number lines as we go along. OK? Number lines look like this. On a number line, if I was to say, and this is one of your homework assignments, might be one of your homework assignments. If I was to say, plot 3 on the number line, where would I put a little dot? This is not rocket science, right? There's 3. OK? If I was to say plot -2, boop, you'd put a little dot right there, and that's -2. OK? When we talk about these numbers, I already did one on the board a little earlier. When we talk about these numbers, if you look at those 2 numbers, -2 versus 3, okay? We did this earlier. We've got -2, which is smaller than 3. We call that less than, okay? And I don't mean to insult anybody's intelligence on that, all right? But we got to at least get this down. That's negative. What if I put the 3 here and the -2 here? 3 is greater than -2. Everybody with me so far? All right. This stuff, so far, so good. How about this? -5, -7. -5 is actually greater than -7. If you look at the number line here, the numbers get bigger this way in the negative direction and get smaller, and they get bigger this way as well. And 0 is right there in the middle. OK? So -5 is greater than -7. On the number line, it would be -4, -5, -6, -7. Right? So -7 is farther this way, meaning it's greater on the number line. OK? All right. Any questions on that? OK. So far, we're good. Again, we're starting out relatively slow, but we want to be able to get this stuff down. OK. What's the difference between -3 and 3? Good. I should have phrased this a little different. The difference, yes, it's 6. There's 6 different if you're going to find out how far between each other they are. But what's the difference just in general? What if I take -3 and I go boop, then it becomes 3? It's just one's positive and one's negative, right? If we want to know of an integer how far it is from 0, okay, we call that the absolute value. The absolute value, value is the distance of a number from 0. Okay? That's the absolute value of a number. OK, this is actually one of the easier things here to try to figure out. If I said the absolute value of 6, you would write down 6, right? If I said the absolute value of -6, you would write down 6. OK, easy stuff, right? We're going to use that in a few minutes when we talk about adding and subtracting. And again, I am not trying to insult you here by going this stuff fairly, this early stuff fairly, in depth. But when we get to some actual problems here, we'll get to a point where you're going to go, OK, I got to think about some of this stuff for a minute. OK, all right. So that's the absolute value. OK, what if I said the absolute value of -2 plus the absolute value of 3? What would that be? It would be 2 plus 3 equals 5. OK, good. So far, you guys are superstars. OK, if I gave you a question on this stuff, you would be able to say, I got it. All right, let me erase this. All right. OK, let's just talk about addition for a minute. How do we add integers? Pop quiz. What's the difference between integers, natural numbers, and whole numbers? Natural numbers don't have 0. Whole numbers don't have negatives, if you want to keep it that way. And integers are the ones that have negatives and positives, the whole line. OK, if we add integers, OK, we have to be able to add both positives and negatives and negatives. OK? And this sounds pretty easy, right? If you go to page 241 in your book, you don't have to do it now. Don't worry. I mean, if you want to, you can. But there's a little rules in there. Page 241, there's rules for how you add these things together. OK? Let's say you go to the mailbox. OK? You go to the mailbox, and you have 2 letters. And by the way, did you guys hear that supposedly, if you're not putting the whole 9-digit zip code on your packages, they're returning them? well, first of all, I think that's illegal. I don't think they should be doing that because last time I looked, you don't need it. But 09363, is that it? Dash 0001 or whatever your box number is. If you don't put that on there, supposedly they're sending your packages back. So make sure you tell family, friends, Amazon.com, whatever, that you need to put that on there. I haven't, well, I don't know. I haven't, maybe that's where our calculators are. I don't know. But anyway, oh, speaking of calculators, while I'm thinking about it, we will have, if you want to use a calculator in this class, you are welcome to use a calculator in this class. Okay? I don't really care. The thing about calculators, I think everybody will be able to have one that looks just like this. It's got some special numbers on there. One looks like this, which is what? Square root. The square root formula button, which is on there. Okay, it's hard to do square roots in your head, for what it's worth. Well, it takes a little practice anyway, especially to get decimals and things out of it. But calculator like this, which we will all hopefully have if they come in the mail by, say, next week or whatever. I'll be able to hand these out. If you want, use a calculator on your phone, use a calculator on your computer. I don't really care. Okay, on the final exam and the tests, we'll have to have calculators that don't have like memory and all that kind of stuff, like special stuff on them. So you can't cheat, I guess. But as far as it goes, the problem with everybody having different calculators is all the button presses are a little bit different. And that gets annoying because then I have to go, OK, first you hit the square root button, then you hit this. But in some calculators, it's the other way around. And it's kind of a pain. But we'll all figure it out. So you are welcome to use calculators in here for most of this stuff. OK? All right. Anyway, you go to your mailbox. Right? You go to your mailbox, and you find that there are two checks in the, well, there's two, I guess they're not, one check from your insurance company. Okay? There's a check from your insurance company. It's $30. Okay? Why? You were driving the gator around, somebody rear-ended you, and you get a $30 check from them, right? If you have a gator at home, I guess. I don't know. So you get a check for $30. You get a check for $30. You also get a bill, I don't know, a cell phone bill for negative $50. How much has your net worth changed? Your net worth is now 30 plus negative 50, which happens to be negative $20, right? So your net worth has changed negative $20, okay? This is typical of the kinds of things we will be adding when we're doing this, okay? We can do it on a number line, but really I'm not gonna make you like worry about jumping all around on a number line if we can help it. Really, we're just got to learn the rules here, okay? And we'll figure those rules out. Like I said, they are on page 241 in your book, okay? You kind of have to memorize them if you don't remember how to do this stuff, okay? If you don't remember how to add or subtract negative numbers and positive numbers together, you got to memorize it. Let's go through all the different examples we could. It's really not that many, okay? Rule number one, of the rules, if the integers have the same sign, okay? Let's do an example. 2 plus 5, or, I don't know, let's do negative 2 plus negative 5. Why not? If the integers have the same sign, here's rule number one, okay? Add their absolute values. Fair enough. What's the absolute value of 2? 2. What's the absolute value of 5? I assume you guys know how to add. If you don't, use your calculator, right? OK? 2 plus 5. Add those together. You get 7. OK? We're not done yet. Then it says the sign of that answer is the same as the sign of the two numbers, because they're the same sign. In this case, positive 7. You don't need to write the positive. OK? You can, but you don't need to. I think the homework thing will accept positives, even if it is positive. But we'll have to figure. Remind me to check that. OK. Isn't this the same set of rules? Negative 2 plus negative 5, are they the same sign? They are indeed. So we do the absolute value of negative 2, 2. The absolute value of negative 5, 5. 2 plus 5 equals 7. The sign, though, it's negative. So rule number 2 says use the same sign. So negative 2 plus negative 5 is negative 7. All right. Everybody think they can do that?
Yeah.
Yep.
All right. Again, this stuff, not rocket science. I don't think we're going to get into any rocket science. Maybe a little. I don't think so. OK, so what's the other type of example we can use? If they're different signs, and I bet the rules tell us that. Let's say negative 2 plus 5, or let's just do it the same thing, 2 plus negative 5. Okay. All right. The rule says subtract the smaller, if they have the different signs, subtract the smaller number from the larger number. Now we got to do this subtraction. I know we're adding, but we have to subtract because that's the way it works. Okay, subtract, well, it says subtract the smaller absolute value from the larger absolute value. Which one here is smaller? The 2. Not going to insult your intelligence, right? So what's the absolute value of this one? 2. Absolute value of this one? 5. 5 minus 2 equals 3. And if the answer is 3, and then it says, rule number 2, the sign of the sum is the same sign as the number with the larger absolute value. The 5 is larger, so it's going to be this, so it's going to be positive 3. Okay? Look at this one. Same thing. 2 and 5 are the absolute values. You subtract them because they're negative signs. 5 minus 2 in this case is 3. Okay? Which one's bigger? Still 5. Now it's going to be the answer is going to be negative 3. OK. You can run through that, what we call, that's called an algorithm, actually. If you want to be technical about it, you can run through that and do that each time, or you can just do enough of these problems so it kind of becomes natural to you. OK? All right? All right. Do this one on your paper right in front of you right now. Let's try negative 17 plus negative 3. Boop. And if you didn't memorize the rules yet, that's fine. It's on page 241. Negative 17 and negative 3. Now, again, I'm not going to insult your intelligence. If I ask you to do a problem, please do it. If you don't want to, I'm not going to push you to the extent that I just figure you're not going to want to put in the time. But please do if for what it's worth. Negative 17 and negative 3. The signs are the same. What were the rules for the signs being the same? Anybody remember? Add the absolute values. That would be 17 and 3, which the absolute value is, added together, 20. OK, and then the sign is same sign, negative 20. Make sense? All right. All right. I'm not going to belabor the point. If you can't do this stuff, the homeworks, you got to practice the homeworks and learn those rules. OK. All right. Subtraction, on the other hand. OK, subtraction. Well, I bet the book also has rules for subtraction. Oh, let's see. Does it? Oh, actually, you know what? Rules for addition might not have actual rules. But let's see. Well, subtraction in this case is just adding the opposite. So I guess it doesn't need rules. The rule is add the opposite. There's your subtraction rules. OK? So if we said 5 minus 2, add the opposite. 5 plus negative 2. OK? If you want to do that. Now, we already subtracted 5 and 2, so I mean, that's kind of silly, right? But if you want to make it a little trickier, you can say, well, negative 5 minus negative 2. And I'm going to write it like that. Well, what do? We add the opposite. So you can say instead of negative 5 minus negative 2, you go negative 5 plus 2. And in this case, what is that? Negative 5 plus 2, different signs. Let's go through let's just go through it for now. Add the absolute values, right? I'm sorry, I lied. Subtract the bigger absolute value from the smaller one, right? OK, so it's going to be 5 minus 2, 3. 3, there we go. 5 minus 2 is 3. And then what's the sign? It's the sign of the bigger one, negative 3. OK, negative 5 minus negative 2. Sounds weird when you say that. But the answer is you do exactly that. You say negative 5 plus 2 gives you negative 3. So this is negative 3. OK? Any questions on that? OK. All right. If I'm already going too fast for any of you guys, that's fine. You just got to know you got to put the time in to try to get this stuff later. OK? All right. So that's subtraction. Well, we can try another one. 2 minus 7. Minus 5, sure. Okay. And you know what? You did that because you remembered it from whenever you did math before, right? 2 plus negative 7. Same thing, different signs now. 2 and 7. You do 7 minus 2, and you get 5. And it's the sign of the bigger one, negative 5. Done. OK? All right. I know that was a fast example, but I think you guys can get that sort of stuff now. We'll go slower when we need to. Okay, but if you have questions, please let me know. OK, so that's doing that. Now, we've done addition, subtraction. Let's do multiplication. OK, multiplication. Multiplication is repeated addition, if you want to think of it that way, right? 4 times 3. Now, by the way, I'm going to put 4 times 3. I could also put 4 with a little dot 3. I could also put 4 in parentheses next to 3. All those things mean multiplication. OK? Get that one in your brain when you're thinking about this sort of stuff. OK? 4 times 3 means 4 3 times added together. 4 plus 4 plus 4 plus 4, which in this case equals 12. 4 times 3 is 12, right? Thank you very much. 4 times 3 times, which is 12. OK? Same thing with this one. You could think of it as 3 4 times, right? That one maybe I'll do right this time. 3 plus 3 plus 3 plus 3, which equals 12. OK? You could think of this as, well, this is for positive numbers, right? Now, when you're multiplying negative numbers, things get a little bit strange, right? Things get a little bit strange, and you guys might remember this from whenever you took a math class before. But 4 times negative 3, yeah, it's negative 12, but for anybody who didn't like instantly get that, right? This one is negative 3 4 times, added 4 times. Negative 3 plus negative 3 plus negative 3 plus negative 3 plus negative 3. Right? If you added all those up, you'd get negative 12. Right? And you could use your rules to do that if you didn't know how, et cetera, right? So that's it. I don't think we really need to go into why that's the case unless you want to. I mean, I think it's one of those things where in the big picture, I care about 2 things. I care that you understand the stuff like why, but really sometimes, unfortunately, taking the time to understand the why is more about like digging into it yourself sometimes. Like I'm not going to sit here and spend 10 or 15 minutes talking about the why behind this. You know, maybe if you want to know that stuff, ask me later. I'm more worried that you know how to do it at this point. OK? We're all in college. We're trying to get the hows down to make sure you pass this class. OK? So a positive number times a negative number is a negative number. Here's the way you figure it out if you have a whole string of them. Let's see. Let's put times 2 times negative 1. Count up the number of negative signs. In this case, it's 2. Is that an even number or an odd number? It's an even number. If you have an even number of negatives and you're multiplying everything together, the answer will be positive. Okay? If you have an odd number of negatives, the answer will be negative. Okay? So that's the easy way to remember it and do it. In this case, it would be negative 1 times, let's see, 1 times 2, it's 2. 2 times 4 is 8. 8 times 3 is 24. How many negatives do we have? 2. So this has got to be a positive number. If I had changed this to 1 times 2 times 4 times negative 3, it would be an odd number, so it's negative. OK. All right. I see you guys are like, getting this stuff. And if we're going too slow, or yeah, if we're going too slow, great. Not going to have to worry too much about this stuff. OK. So that's negative numbers multiplying together. OK. All right. We've done addition, subtraction, multiplications. What's left? Division. Division ends up talking about fractions. For whatever reason, some people hate fractions. Like you did it in 2nd grade, and you did it in 3rd grade, and you did it in 4th grade, and you did it in 5th grade, and you'd think by then you'd be able to knock out fractions. People still, they get to be like 20s and 30s years old, and they're like, I don't know how to do fractions, right? And it's not that it's that hard. It's just like remembering some of the details about it get a little bit tricky, and then you don't use it that in everyday life. Well, you probably do to some extent, but you don't use it all the time in everyday life. OK, so dividing integers. Again, we can write this in a couple different ways. We could go, let's say we could go 12 divided by 3. Notice that looks like a little fraction symbol. That's where that came from, right? 12 divided by 3. You can also go 12 divided by 3. The little slash symbol sometimes mean that. OK? Or we could just do the straight up fraction, 12 divided by 3. They all mean the same thing. Oh, I guess you could do this too. Yeah, you could say 12 divided by 3 if you want. OK, everybody familiar with all those ways of writing divided by? OK, well, division is just repeated subtraction. It's kind of like addition was, or multiplication was a repeated addition. Division is repeated subtraction. But again, I'm not going to stress that you guys know how to do, like you know that part of it. I don't really care. I want you to know how to do the actual division. OK, dividing is much like multiplying in terms of the signs you use, although there's really only 2 cases. OK, 12 divided by 3. That equals 4. We know how to divide fairly easy numbers. If you need to do it this way, you can. And if you want, I can go over how to do this later. But really, in this case, if you're not good at, like, I'm not going to make you do this, but something like 3 into 1, 2, 3, 4, 5, 6, right? Well, really use your calculator. I mean, when it comes down to it, use your calculator for this thing, right? So, but we may have to do some things like this by hand, but not much. OK. Dividing a negative number by a positive number. What's the answer going to end up being? Negative. It's negative. OK. What if you divide a positive number by a negative number? Also negative. OK. If you divide a negative number by a negative number? Positive. OK. Those are your rules, right? OK. There's a couple other weird ones in this division thing. What is 0 divided by 125, 6, 3, 8, 2? That equals 0, right? OK, well, in that case, what's 1, 2, 5, 6, 3, 8, 2 divided by 0? 0. You would think it would be 0, right? Because why not, right? I mean, it's no big deal. No, this actually does not exist as a number. It's impossible to divide 0 things into something else. It just doesn't work out. And you can spend like a whole semester of math classes worrying about why that's the case. But just for now, know that that is the case. In the homeworks, sometimes it will give you choices. And one of the choices will look like this. A little curly bracket with a little 0 with a line through it, and then another little curly bracket. That means it doesn't exist. OK, it's like the empty set, which means this doesn't actually exist as a number. OK? All right. So don't try to divide anything by 0. It may ask you sometimes to divide things by 0. So you may see something like this. 17 divided by 4 minus 4. Right? We'll talk about how to do the order of operations on this later. But that's going to be 0. It's going to be non-existent. It's not going to be 0. This is going to be 0. So this is going to be 17 divided by 0. Can't do it. Does not exist. OK? Why? Don't worry about it so much. I mean, if you want to worry about it, go read about it. It's not, it's just, you just can't do it. So we're not going to be actually, you're not able to do it. Even by the way, if you typed it in your calculator too, it would say error or give you nonsense or something like that, right? OK. All right. So I tell you what. We've been sitting here almost an hour already. Let's take our break. Go if you can run, get your dinner or whatever. But come back, tell you what, in let's say 15 minutes. At 20 after, I'd like you back. OK? Thank you. OK, before you guys get too far on the order of operations, because I know that might be a little new for some people, let's go over the ones that we already did, any ones you had questions about. The number line, I did the number line up here. Negative 3.8, you kind of just got to guess on number lines. Right? You kind of just got to say, OK, right about there. It's more closer to 4 than to 3. And it's about 0.8 away from 3, et cetera. The ones closest is a little tough to see. 0.1 is on this side of 0. Negative 0.1 a little bit on this side of 0, et cetera. 2.5 in the middle. Any questions on that? I don't think that stuff's too tricky. OK, the absolute value ones, I looked around. A couple people were forgetting that the absolute value sign, right? If this is the absolute value sign like this, and it's like negative 3 plus positive 3 absolute value, right? First you look at what's the absolute value of this? 3. The absolute value of this? 3. Answer is 6. OK, if you mess it up, that's cool. It's just you got to just learn that first you do the absolute value signs, then you do the operation.
It's never going to be a negative then.
It is never going to be a negative. It could be 0, but it's never going to be negative. And the only way it could be 0 is if both of them are 0. Yep. Although, well, it could be negative if this was negative, right? Yes. Like, let's say this was negative 6 minus 3. You'd get 6. Oh, that wouldn't be. Sorry, the other way around. Sorry, let's say it was negative 6 and 3 or something. Did I do it wrong again? I did it wrong again. I'm a moron. OK. Hold on. Negative 3 minus 6. Right. That would be 3 minus 6, which would be negative 3. So yeah. You can, if you're multiplying, you won't get negative numbers because they're always going to be positive times positive. OK? All right. Any questions on this stuff before we go to the order of operations? OK. Let's do this. Let me take a few minutes to show you the homework system. OK? Show you the homework system. I'm going to have to erase this. All right. OK. If you could, if you haven't signed up for this, please do so by tomorrow, only because I want to make sure you're able to before class. Like if you haven't purchased the book or the code, you actually can get on the system for like 17 days before you have to do that. So if you're waiting for financial aid or anything like that, you can get on for like 17 days to do that. When you log onto the system, you'll get this little screen, OK? And I think your screen will be similar. I'm not. Is it about the same as this? OK. You'll have your little class that you click on, OK? And hopefully it will come up. And it will show you all of the assignments, OK? Homework, quizzes. I'm not going to give any quizzes and tests online. I may give some review stuff online, but nothing will ever be graded that's not homework for online stuff, OK? Just so you know. So you can click on homework, and then it will list pop-up blocked. No. I don't know why it's, well, anyway. OK, so here's all the assignments. These are the sections that the assignments are from. Hopefully you can see that. Let's click on assignment 1. A couple things about this. OK, you can see all the different questions here. I said there are 84. I know it seems like a lot, but they go by pretty quickly, right? Especially this first one will go by really quickly. Jeremy said he did them relatively quickly. OK, so if you click on the question, OK, once it pops up, OK, it's pretty simple. Either it could be multiple choice, like negative 17 is blank of 2, greater than or less than? Less than. I'm going to choose greater than because I'm not so clever, right? If I click final check, it will say, no, you can't, wrong, OK? I think this is possible. At least on mine it does this, but I'm the instructor, so maybe it won't. If you click down here, similar exercise, you actually get to redo it. And then you can count that, I think, I hope. You can count that. So negative 4, have you tried that? Yeah, good. Negative 4 is what to 4? I went and studied, so now it's less than. I know it's less than. Final check. Ta-da, good job. Now if I click to go to the next problem, actually it just counted it. So I think you can go back and change that. So what does that mean? It means everybody could get 100% on all their homeworks, right? And I don't have it here, but I forget what the homework grade is, but it's something like 30% of your grade or something like that. I mean, it's pretty significant, OK? So I want you to be able to take the time you can do this to learn it. And if you don't know how to do it, redo it until you get the right answer. I mean, figure it out. Yeah?
Well, if you try and log on to this at work, that link might try and convert you to another.
No kidding.
Site, so it'll give you back to this part.
OK.
But the original link you can't get into it. It's trying to come back. It's not fun.
Really? So www.mymathlab.com doesn't get you there?
If you click on my courses, it'll try and redirect you somewhere else.
Oh, interesting. OK.
But it'll be just the same spot.
If you have trouble, if you're doing it at work, let me know. I think we should be OK. The J6 people tell me that we can get to this website from there. So it worked eventually, but OK. All right, thanks. If you have troubles, we can do it after class or whatever. If you try it tonight and try a couple of problems, or if you want to go to work or whatever and do it, then we'll come back tomorrow. We'll figure it out. Or this week we'll do it sometime. OK, so a couple other things about this. So some of the things we're going to get into, in fact, in a few minutes, are like fractions, right? In order to type in fractions, sometimes, let's do this. Here we go. So it's a little tricky to do the first couple times you try it. notice over here there's a little box here, and we're going to do the fraction now. We haven't learned this yet, but let's do this right now. 2/7 minus 9/10. We'll go over how to do this in a few minutes. You have to find a common denominator. I don't know if you remember all that, right? The common denominator between 7 and 10 is 70. So what you're going to do is, I'm going very fast just to show you how to do this, right? So let's see, if it's going to be 70 down here, this is going to be 2 times 10, which is 20/70ths, right? Minus 10 times 7 is 70. So that's going to be 9 times 7, which is 63/70ths. 20 minus 63. It's exactly like doing plus a negative number. You subtract them. This is going to give you negative 43/70ths. Everybody agree with that? Even though I went really fast on that? OK, negative 43/70ths. If we try to type that in, it's pretty simple to do, actually. You can do negative 43, and then you can hit the divided by symbol, the little slash, and it will actually bump your cursor down to there, and you could do 70, right? OK, that's one way to do it. Or you could do this. There's a little section of stuff over here which has the little icons that show. So I'm going to do a fraction, and I'm going to click on the fraction. Then it gives you a little icon with the boxes already there. OK? 43/70ths. 43 negative 70. Is that the same answer?
Yes.
It actually is. I think it will accept this. You will find that sometimes it doesn't accept this, and you will want to throw your computer on the ground and stomp on it and whatever. Do the best you can. If you cannot figure out how to put the right answer in, let me know. I will instantly give you the right answer. I mean, give you credit for it. I mean, I will change it so that I will not. I don't want you to sit there for hours and figure out why you can't get the right answer in the thing. If you're getting the wrong answer, well, then we have to figure out why. But if you are dead sure you got the right answer and it's not accepting it, try to put it in again some other way. If you can't do it, just let me know. We'll get that figured out. Anyway, negative 43/70ths, and then let's see, check the answer. Nice work. OK, good job, us. OK, so I think that's about. Oh, I already talked about doing similar exercises. You can do that to redo it. If you don't know how to do it, sometimes you can click on View an Example. It'll show you how to do it. I mean, the beauty of this is this online system gives you all the tutoring you'll need if you don't have it. Like, if you can't contact me or don't want to come, this helps you out. So it's something that us old timers didn't have as a kid, right? I mean, you couldn't do this back in the day, right? But now you can. So it's pretty cool. Let's see. You can also see the whole textbook. I think you get to see the whole textbook if you want, if you don't have it in front of you. There are, let's see, evaluate the following expression. Well, what would be the square root of 36? Anybody know? 6. Let's put in negative 6. Check answer. This actually tells you you've given the negative square root. Oh, all right then. Well, I guess it won't let you do it again. Oh, it will. Maybe in this one it will. Yeah, I think this one, it'll let me just do it again like that. So do that. OK. Any questions on this stuff yet? OK, does anybody know Paul? Well, I tell you what, the people who are here tomorrow, we'll get them again. I'll do a little tutoring session with them again. OK. Anything else on this one? OK. All right. While I've got the computer on, I might as well do this right now. The next thing we're going to talk about is this order of operations. And what I have is, oh, by the way, oh, I don't have it up yet. Hold on. OK. Let's see. There we go. You can actually download an online calculator that has the same exact button presses as the calculators that we're going to hopefully use in class. I will show you these sometimes. Like I will say, we're going to do the square root of 65. Well, in this case, you type the square root button, which is, well, on this calculator, you have to hit second and then square root, and then 25, like that. Enter, and it gives you the answer is 5. So you see how I'll show you sometimes how to do it on here, but no worries about that. OK, let's see. This is what I wanted to show you. Some of you guys already remembered order of operations, but let me show you what this guy has to say about this. This guy says the order of operations is wrong. In fact, he says it's morally wrong. which I think is kind of funny to have something morally wrong in math, but hey, that's the way it goes. Okay, let's see if this comes up.
If you went to elementary school in the US, or much of the rest of the world, you almost certainly learned about something boringly called the order of operations, a set of rules for whether or not you should do multiplication before addition or addition before subtraction to get the right answer on your math test. Except you don't always get the right answer, or even one answer. I mean, is 8 minus 2 plus 1 equal to 5 or 7?
Stop. Is 8 minus 2 plus 1 equal to 5 or 7? Do you do 8 minus 2 then plus 1? In which case you do 6 plus 1 equals 7? Or do you do the plus first because PEMDAS A is before S? Which one is it? Anybody know? Yeah, it's actually the bottom one according to our rules. And by the way, order of operations is all about rules. Don't worry. By the way, you don't have to like memorize what they're talking about in here. They go through it pretty quickly. Some of you guys might have seen on like Facebook, there's somebody put a big like order of operations thing and say half the people get this wrong, and then it's this exact sort of thing. They just don't remember exactly how to do it, or they never learned it properly. Anyway, I digress.
And is 6 divided by 3 divided by 3 equal to 2/3 or 6?
We will not do ones like that.
The problem is, focusing on the order of operations can lead to ambiguity and obscures the real, underlying, and often beautiful mathematics. A mathematician will tell you that 8 minus 2 plus 1 is really 8 plus negative 2 plus 1, which is unambiguously equal to 7, even though the so-called order of operations standard in the US tells you the answer is 5. If you want 5 for your answer, then you really need some parentheses. But why is this ambiguity even possible? It's because fundamentally, all of these operations are simply different procedures that start with 2 numbers and combine them in some way to give you 1 number. Each operation takes 2 numbers as input, 2 and no more. If you want to be entirely unambiguous and pedantic, every single pair of numbers in any algebraic expression should be inside parentheses. And then there's no need to know any order of operations. Just evaluate the innermost parentheses first and work outwards, collapsing them down pairwise like a championships bracket. But it turns out that's not the only way. It's possible to change the order in which you do the operations, to rearrange the parentheses, as long as you know what the underlying mathematics is. For example, if you want to add 3 plus 4 and then multiply the result by 5, you can either do the addition first and get 7 times 5 equals 35, or you can do the multiplication first, as long as you know that multiplication distributes across all the terms in the parentheses. That is, 5 times 3 plus 5 times 4 equals 15 plus 20 equals 35. The same answer. And how do we know multiplication distributes? One way is to draw rectangles, but I've done that before. The same rearranging can be done for exponentiation and multiplication. 3 times 2 all squared, or 6 squared equals 36, is the same as 3 squared times 2 squared. 36. It even works for addition and subtraction. 5 minus 1 plus 2 is 5 minus 1 minus 2. So the true order of operations is this. Use parentheses and learn what exponentiation, multiplication, addition, and the rest are really doing. Then you can proceed however you want. That's not to say that we don't have a conventional order of operations in mathematics. I mean, deciding that we evaluate multiplication before addition allows us to get rid of lots and lots of redundant parentheses. And noticing that 1 plus 2 plus 3 equals 1 plus 2 plus 3, and 2 times 3 times 4 equals 2 times 3 times 4 removes a ton more. But the point is that those parentheses are still there, still implied, just like how 3 minus 4 is secretly implying 3 plus negative 4, and 3 divided by 4 is really 3 times 1/4. But anytime the result might be ambiguous, you really need to use parentheses. Then you can proceed in whatever order you want. The order of operations learned in school, however, is different. It's a mechanical set of instructions that dictates just one of the many ways you can do algebra. It locks you into a single path through the beautiful mathematical landscape, which, while necessary for a computer whose goal is merely to give you the right answer, doesn't really give any insight onto what it is that you're doing when you do algebra. So while the order of operations isn't technically wrong, because most of the time it'll give you the standard answer, it's morally wrong, because it turns humans into robots.
Okay, so
This Minute Physics video was brought to you by Squarespace.
All that said, I'm going to kind of turn you guys into robots, right? I happen to think math is pretty cool, and you may as well. And if you do, that's fantastic. That's not necessarily the goal of this course right now, just because we want to get you to, get get this stuff done. But we do need to learn this order of operations. Despite being morally wrong, we have to learn a little bit about this stuff. Okay? Any questions on the video? No? Okay. I'm probably going to, that's probably really bad teaching where I tell you something's morally wrong and then go ahead and teach it to you. But we'll learn how to do this stuff. Okay, order of operations. Okay? When you add and subtract things, it's exactly like that guy was saying. You can have a bunch of operations, 8 divided by 4 plus 3 times 6. Right? 8 divided by 4 plus 3 times 6. You have to know how to do that because everybody might do it a little bit differently. Some of you guys might do 8 divided by 4, then plus 3, then times 6. Or you might do 8 divided by 4, and then 3 times 6 and add. Or you might do 4 plus 3. You got to know, we all have to be on the same page here. It's kind of like traffic signals, right? Everybody knows that when you have the green, you go through. And if you have the red, you stop. Otherwise, if you didn't know that, well, in Djibouti, they might not know that, but it's a different story. You know, it was only like 8 months ago they got the first stoplight in Djibouti. Crazy, yeah, crazy, crazy. Okay, so the order of operations. Okay, we're going to do this. We're going to learn this PEMDAS thing, but I'm going to do it the correct way. Okay, first thing you do is parentheses. Parentheses. Okay, then you do exponentiation. I'm going to write exponents. Okay? Okay, PE, and then you do multiplication or division. And you do this left to right. In other words, you go along and you go, which one, is it a multiplication or division? Left to right, you do that. Then you do PEMDA, addition, or subtraction. And you also do it left to right, GHT. Okay? Left to right. Okay? PEMDAS, but remember, these ones are left to right. Okay? So in this example, let's do this. 8 divided by 4. Is it a parentheses? No. Well, are there any parentheses? No. Are there any exponents? No, we're not even going to worry about exponents quite yet. Okay? Is it a multiplication or division? The first one, yes, there it is. Let's do that one. 8 divided by 4 is 2. Okay, you put that there. Now you get to the next symbol, left and right. It's an addition. We're not doing that yet. We're still working on multiplications. So where's the next one that's a multiplication division? This one. 3 times 6 is 18. Now we've got the addition in there. 2 plus 18 is 20. There's your answer. Okay? This is not that hard. It's just, you know, you gotta figure it out. Okay? All right. Let's do a couple more examples. In fact, let's do a couple of the examples on your worksheet right here, because we can. Okay? So on the bottom of the page, there's order of operations. Okay. Some of you guys have already done these. Tell you what, let's start at number 10. Thank you. Sorry? 7 is hard? OK, let's look at 7. Number 7 on the back of the page says 3 with a parentheses, 6 plus 4, and then another parentheses, 5 minus 3. OK, let's look at our rules. PEMDAS. OK, are there any parentheses? Obviously, there are parentheses. So we do those first. 6 plus 4 is 10. There's some more parentheses. 5 minus 3 is 2. Anybody confused yet? Did everything in the parentheses first. And by the way, inside the parentheses, if there's more parentheses or if there's more than 2 things, you have to do those in the right order as well. Gets a little tricky. If we put parentheses, if we leave the parentheses there to do this, this really looks like this. I put an extra set there. Now what do we do? This is multiplication. 3 times 10 is 30. And then we can do times 2, which gives you 60. Now, did I do that right on here? Number 7, I didn't. That's why it's wrong. So it's because I screwed up. Not 67, thank you. Too bad, I thought I checked all these. Anyway, There you go. OK, did anybody get 67 and thought they got it right? No. OK. You've been trying to get 67? Oh, no. Well, don't always believe your instructor. I make mistakes, too. OK, let's look at 10. That's an easy one. 24 minus 6 divided by 2. Parentheses first. 24 minus 6 is 18 divided by 2 is 9. Did I get that one right?
Yes.
I did. Good. Whew. I'm not so crazy. OK. All right. All right. Let's look at some harder ones on here. Let's look at, how about 14? 14 says, parenthesis, 2 parentheses, 9 minus 4, and then squared, times 2, parentheses, plus 6, plus 7 squared. We've got almost everything in there, except the divided by. OK. All right. First step, parentheses. Here's some. There's also these out ones, but you got to do the inner ones first if there's inner ones. 9 minus 4 is 5. OK. What I do is I normally write the whole thing again if I have to. If I really need to concentrate on this, I'm going to write the whole thing again. OK. 5. Can you guys see when I stand right here? OK. 5 squared times 2, parentheses still, plus 6 plus 7 squared. OK. There's still parentheses? Yeah. Inside those parentheses, we've got an exponent and a multiplication. Which one do we do first? Exponents. 5 squared is 25 times 2. We might as well knock this one out right now. 25 times 2, 50. And then we have plus 6 plus 7 squared. OK. 50 plus 6 plus 7 squared. Now we got to go back to it again. What's left? An exponent. That's going to be 50 plus 6 plus 49. Now all we've got left are positives, so we do addition. 50 plus 6 is 56, plus 49 is 105. Did I get that right? Upside down? Yes. OK. Questions on that? Good. You guys have all seen this before, right? OK. If you haven't, let me know, and we'll work on it and figure it out. Let's do one more before we go on to 5.3. Did you get the flag down? Good. I showed everybody how to use the online homework thing. If you want, I'll show you after class or tomorrow, either way. OK, let's do one more. Let's look at, what do you think, 15? 20. We'll do 20. Let's do 20. 20, 2 parentheses, 11 minus 4, n parentheses squared. This is almost like the one we just did, actually. Times 5 minus 13 plus 2 squared. Did I miss something? Oh, thank you. There we go. OK, so first thing we do, parentheses. Here's one. We don't worry about the outer one yet. 11 minus 4 is 7 squared times 5. Keep the parentheses that are still there. Minus 13 plus 2 squared. OK, it's 4. And then now we do parentheses here. Well, what's in there we have to do first? Exponent. 49 times 5. Parentheses minus 13 plus 2 squared. OK, 49 times 5. Let's see, 50 times 5 is 250, so subtract 5 away because we're only doing 49 of them, 245. You guys can do calculations in your head sometimes too. I'm terrible at it, but every so often I get it right. 245 minus 13 plus 2 squared. What's next? The exponent. 2 squared is 4, so I'm going to put this in there. 245 minus 13 plus 4. What's next? Do the subtraction left to right. 245 minus 13 is 232 plus 4. 236 is our answer. And I did get that one right. OK. Anybody have any questions on this stuff? All right. I'm not going to make you do all the rest of these now. Maybe at the end of class we can work on some more if you haven't done them. Sorry about the ones that are. Anybody find any other mistakes I made? No? OK, good. All right. So we have now completed section 5.2. Woohoo! By the way, that was as far as they got in the last class the first day, so I guess we should be happy. If I'm going too fast, let me know. If I'm going too slow, too bad. Don't worry about it. If I'm going too slow, go, good, I can get this stuff. Or you can like change to like an online calculus class or something, whatever you want. All right. Does anybody already have a college degree? Sometimes we get people who are doing another college degree, no? Who's studying humanities, like English or history or something like that? Anybody? You might not know yet. What are you studying?
World religions.
World religions, OK. Good, excellent. Who's studying like business? Anybody? Got to be a couple of you guys. A few business people? Let's see what else I can get. Anybody doing something with computers, networking, anything else? OK, how about, let's see, what else am I missing? Criminology or something, OK, a couple of that. Oh my gosh, what else could you guys be studying? Anybody doing science, straight up science? No? Let's see. Philosophy, psychology. General? Anybody doing general? Anything you don't know yet? OK, what are you doing? I didn't.
Oh, you got mine.
What oh, criminology, OK. Did I not get somebody's? Oh, I got everybody's? Oh, whew, OK. Thought I was losing my mind. OK. There's some strange majors out there. Some schools you can do really wacky majors. I know there's even schools where you can make your own major up. Like you just take a whole bunch of courses, you get an advisor to buy off on it, you get a degree. You know, whatever. It's a little weird. OK. All right. So here's what we've done so far. We've done integers, whole numbers, natural numbers. Now we've got to do what's called rational numbers. OK? Rational numbers are numbers that don't fit into the previous category, but there's actually other categories too. Okay? But rational numbers are numbers that can be expressed as a fraction, a over b. Okay? And a over b are both integers. Okay? So if you can represent it like this, then it is what's called a rational number. We will eventually talk about numbers called irrational numbers, which there's a real famous one called not negative square root of 1, good, or square root of negative 1, no. Who said it? I heard it back here. Somebody said it, pi. Yeah, pi is not a rational number. You can't figure out how to get two integers, one on top of the other, divided by like this to make pi. It's impossible. We've proved that. Da-da-da. We're not worrying about that number now. OK. We are worried about numbers that you can represent as a divided by b. OK? A is called the numerator. Numerator. B is called the denominator. Denominator. Do I care if you know those names? I do, because I'll mention them a lot of times, and then you'll need to know them. I don't care that you know. In real life, you ever called it? No, you don't, right? But in math class, you have to know them because I'll use that term. You got to know what they mean. Numerator and denominator. OK? Is -1 a rational number? This is actually a trick question. And I heard a little tentative yes. I saw some nods here. Of course it is, because what can you always do to an integer to make it a fraction? Put it over 1. That is now a rational number, and it means the same thing, so it is rational. All integers are rational numbers. It's like categories, right? All integers are rational numbers. All rational numbers are not integers. We'll get to that. OK? So that's an example of an integer. How about 4? Also a rational number. How about 2/3? Is that a rational number? Is it a fraction? Are both of these integers? It is a rational number. Now, if we were to divide this on your calculator would say 0.66666666667, because it rounds that last little bit, right? It's still a rational number, even though this goes on forever and ever and ever. OK, we'll get to why that's the case in a little bit. Or for that matter, we'll get to how do you convert this into 2/3. That actually, when I was preparing for this class, I had to relearn how to do that. And I've done a lot of math in my life, and I had to relearn how to do that because it's not necessarily intuitive how to do it. We'll get there though. Not hard. It's not hard. It's just you got to learn how to do it. OK, let's see. How about 2 and 1/5? Is that a rational number? You can make it a rational. It is a rational number. This is called a mixed fraction. We're going to spend some time dealing with mixed fractions in a little bit, but it is a rational number. Anybody remember how I would convert that to just one number over the other? Yeah.
Multiply by the denominator, add the numerator.
Good. If you didn't know that, that's OK. We'll learn in a minute. Multiply 5 times 2 and add it to that 1, and you put it all over the denominator. 2 times 5 is 10, plus 1 is 11/5. Those are the same number. OK? One of the things about the homework, sometimes it'll say put it in either this form or this form. I think I found that sometimes you put it in this form and it yells at you. I don't know why. It should accept it. It even says put it in that form. So if it yells at you and says that's not right, try it in this form and you should be OK, or the other way around. But anyway, it's a little bit something wrong with it. OK, so all those are numbers. -3/2, is that a rational number? Yeah. OK. Let's see. Square root of 25, is that a rational number? Why? Because square root of 25 is 5, which you can put over 1, and there you go. OK. Some square roots are not rational numbers. The square root of 2 happens to be not rational. You can't find a number that you can make that into that goes over 1. So is the square root of 2 over 6 a rational number? Are both of these integers? We already said that's not. Even if you put this under, that doesn't magically make this into a rational number. Sometimes you can cheat a little bit if you did. We're getting a little deep into this. Square root of 2 over square root of 2? That is a rational number because those two divide. This goes into this one time. So that is. So yes, don't worry about that yet. Maybe we'll get there in a little bit. Okay? All right. So those are rational numbers. OK. If we have a number, a divided by b, OK, and you have a number c that is not equal to 0. See that symbol right there? That means not equal. OK, if you have some other number c that is not equal to 0, and you write a times c over b times c, guess what? These two numbers are the same. OK? Those two numbers are the same. If you multiply some number, this is going to become really important when we start to reduce fractions. OK, what you're trying to do is get rid of these common factors here. What is 6 divided by 6? 1. What is -4 divided by -4? 1. Anything over itself is 1, right? So notice how c is divided by c in here. 1. Okay? So we'll get to why that's important in a little bit, but no, that's important. Why do they say c cannot be equal to 0?
C was equal to 0. B times c would be still 0. It would be impossible.
Yeah, this would be 0 if that was 0, and this would be 0. What do we say any number over 0 is? Yeah, it doesn't exist, right? Even if we have a rule that says 0 over anything is 0. This is actually defined by mathematicians everywhere to not exist. They probably could have defined it to exist and be 0, but it would have messed up other math. So just if you see something over 0, doesn't exist. Good. OK. So as long as that's the case, these are called equivalent fractions. Equivalent fractions. And equivalent obviously means the same. Those are equal to each other. OK. All right. So how about an example? We can actually show you that it works too. An example. Let's say we have 2 divided by 3. OK. And let's say we have some other number 2. I don't know. We'll make it 4 to be a little different. Another number 4. That is equal to 2 times 4 divided by 3 times 4. OK, let's see if that works out. What's 2 times 4? 8. What's 3 times 4? 12. If you did this on your calculator, you get 0.6666667. If you did this on your calculator, you'd get 0.66667, right? Okay, they are equal. I guess that isn't really proving it, but those two are equal, this and this. Okay, we'll get to how you go from this to this in a couple minutes. Okay, all right. Any questions on that? Kind of step by step. We're building it up here. Okay. All right. Well, let's talk about this right now. If a rational number has no way to, well, how should I say it? Let me give you the exact example. A rational number is reduced to what's called lowest terms. Lowest terms, T-E-R-M-S. Lowest terms if the numerator and the denominator have no common divisors or divisors, depending on how you pronounce it. So let's go back to our other example. 8/12, right? Does something go into both 8 and 12?
Yes.
4 does. We just did it. What else does? 2 does. Let's divide both the top and the bottom by 2. What do we get? 4/6. Guess what? That's also equal to 2/3. Why? Because when you divide, if you divide it out on your calculator, that's it. That's the same way. We could do like pie pieces where we say, here's a pie piece, right? And we have it divided into 3 pieces, right? That part and that part are 2/3 of it. Well, if you divide it into 4/6, you just have 6 pieces, right? It's still the same amount, right? Et cetera, et cetera. So we could go down that route if you wanted to. But this is not reduced, and it's not lowest terms, because there's still a number that goes into both that and that. 2 and 2. 2 goes into 4 how many times? 2. 2 goes into 6 how many times? 3. 2/3 is the same as this. Are there anything else that goes into 2 and 3? Besides 1, which doesn't count in this case. No. OK, that's reduced. OK? All right, let's do a couple examples here. All right, let's do a couple examples here. Reduce 20/55. Now, by the way, this is one of those ones where a little bit of guessing and checking is important here. There are steps to use to always get this right. But I don't want to bother teaching you right now because it just takes a while and they're annoying, and you can do it almost every time by just doing some guessing and checking. Okay? For instance, we all know that if a number has a 0 at the end and a number has a 5 at the end, they're both divisible by what? 5, right? Okay, so 20 divided by 5 is 4. 55 divided by 5 is 11. Are there any factors that go into both of those? No. OK, so that's now reduced. OK, easy enough. OK, let's look at 18/12. 18 divided by 12. What goes into both those numbers? 6 or 3 or 4 or not 4. 2. 4 doesn't go into 18, right? 2 does, though. OK, I heard 6 first. 6 goes into 18 how many times? 3. 6 goes into 12. 2. There's your answer. OK? If you had picked differently, if you'd said, OK, 2, excuse me, 2 goes into 18 how many times? 9. 2 goes into 12 how many times? 6. Do these still have a common factor? You got to do it again. So sometimes you'll do this on your homework. You'll do this on your homework, and you'll put in the answer, and you'll get it wrong, and you'll go, it's got to be right. Oh, it's not reduced. If it asks you to reduce it, you got to do it. Same with on the test. OK, 3 goes into 9 3 times. 3 goes into 6 2 times. There you go. Now it's reduced. OK. All right, let's try one more. Let's try 54 divided by 45. What goes into both of those? 9. 9 goes into 54. How many? If you don't know, use your calculator. If you don't know, want to use your calculator, do the division. Right? 54 goes in 9 goes into 54. How many times? 6. 9 goes into 45. 5. Anything go into both of those? No, this stuff's not that bad. Okay, you do get to some tricky ones where there's more, a little more to it. Okay. By the way, I already showed you this on the homework example when we were doing the online thing. Okay, -2/7 is the same as -2 divided by 7 is the same as 2 divided by -7. Why? Well, the negative sign ends up because -2 divided by 7 the rules say you do one, then divided by the other, and then it's if they're different, it's the sign. It's different, OK? So just keep that in mind. If I write it, I'll rarely write it like this unless it comes out that way in the mix. OK? A lot of times you'll see it like this. OK. All right. So any questions on reducing fractions? I'll ask you to do that. It does take a little time to get it back in your brain sometimes. So don't worry if you're getting a little confused about that. Just practice. OK. We already mentioned this a little bit earlier. Mixed fractions, 2 3/4. OK. 2 3/4 is called a mixed number. OK. And if it's written like this, you can turn it into an improper fraction. OK. Or I guess it's also called an improper fraction. I forget. Yeah, that's all right. That is, yeah, it's called an improper fraction, called a mixed number. OK. If we want to turn it into a proper fraction, we have to do this little trick that we briefly mentioned earlier. OK. What you do is you say this number is 2 plus it's basically 8/4 plus 3/4, right? Common denominators are really going to be important here. OK, making sure that you have a common denominator. How do you get 8/4? Well, you multiply the 4 and the 2 together. OK, so it's going to be 8/4 plus 3/4 is really what you're doing here. OK, you're saying 2 of 3/4, OK, or 2 and 3/4. OK, and then you can add these two together, and that makes 11/4. OK. Let's try another one. How about 5 2/3? 5 2/3. What are we going to do? 5 times 3 is 15/3. I like to write it out this way the first few times I'm doing it. 15/3 plus 2/3 equals 17/3. OK? Questions on that? In a second, we're going to have to go backwards, which is a little trickier, but not particularly hard. OK? If we have something like this, this is one of those ones that gets a little tricky. -3 1/5. OK. That does not mean -3 and 1 like plus a fifth, right? It means this. OK, it means that this part is more tightly bound than the negative sign to this. OK, so do this and then apply the negative. That's the way you remember this. 3 times 5 is 15, plus 1 is 16/5, -16/5. OK, we don't get this that often, but sometimes you'll have to think about it. OK, all right. To go backwards, if we want to go from let's say 17/6 into an improper fraction. OK, what's the steps? Anybody remember this one? Ooh, I'm stumping you all. Good. No, I'm not. Say again. How many times does 6 go into 17? In other words, start dividing it. If you want to do it by hand, you can do it this way. 6 goes into 17 how many times? 2 times, right? 2 times 6 is 12. If you don't remember how to do this division, learn it or do it on your calculator. But calculator's a little tricky with this one, because most calculators won't give you a remainder, which is what we're going to need. 17 minus 12 is 5. Does 6 go into 5 again? There's your answer. So you're going to have 2 and how many sixths? 5/6. OK, that's how you're going to do that. I'll go over another example. Let's do another example. Let's do, I don't know, 31 divided by 5. OK? You can do it the long way. 31 divided by 5. 5 goes into 31 how many times? 6. 6 times 5 is 30. 31 minus 30 is 1. How many times does 5 go into 1? It doesn't. So you've got one remainder. So this is going to be 5 and, 6. Thank you. 6 and 1/5. OK. If you want to do it on your calculator, OK, you have to be a little tricky about it. OK? If you do this on your calculator, who has a calculator right in front of them right now? Go ahead and do this for me. Do 31 divided by 5. 6.2, that's not going to work for this, right? The 6 part is what we want. What's 6 times 5? 30. You got to subtract this, and that's what your remainder is going to be. Okay, so you can do it on your calculator. You just got a couple extra steps in there. Okay, so we do 6, and then we say, oh, okay, now I've got 6. 6 times 5 is going to be 30. Subtract it from 31. 31 minus 30 gives you 1, and you know it's going to be the same denominator, 6 and 1/5. That's how you do that. Okay, you can do it on your calculator, but you can't do it directly on most calculators. Some of the fancier ones you actually can, but sorry. Okay, questions on mixed numbers. We're going to do some mixed number problems here in a little bit. Let's do this. Let's take another break. Okay. I'll try to remember. If we're getting to like 7:15 and we haven't taken a break yet, say, hey, could you come back by, let's say, 25 after today, this time? 7:25. All right. So the next thing we're going to do, we need to talk about rational numbers. Where did my pen go? Here it is. Rational numbers. Rational numbers as decimals. In other words, turning that fraction into a decimal. Okay? Some of this stuff, like I said, if you have your calculator, piece of cake. Plug in the numbers, you're done. Right? If it says turn the fraction into a rational number, in some cases. Okay? Rational numbers, you all know this, but let's do a little review. 342. What does that actually mean for each number? For each digit, I should say. What does this part mean? 300, which equals 3 times 10 squared. This will get important in a minute. What's the 4 mean? 40, which equals 4 times 10 raised to the first power. We haven't done exponents yet, but we're gonna power through, and then if you have questions what that actually means, let me know. And then the 2 is 2, which is 2 times 10 raised to the 0th power. Okay, powers for a second. Exponents are pretty simple stuff. It means multiple multiplication. It's like multiplication means addition a number of times, repeated addition. Exponents means repeated multiplication. And what that actually means is you can represent huge, huge numbers or tiny, tiny numbers very easily when you have this notation. But a couple things you need to know. Any number, a raised to the 0th power equals 1, not 0. This one's a different one. Anyone raised to the 0 is 1. Again, mathematicians, it works out if you define it this way, let's define it that way. And it does, especially when you talk about things like 10 squared, 10 to the 0, right? It makes it easy to do this stuff. Any number raised to the first power equals, not 10, any number raised to the first power is itself. So 6 raised to the first power is just 6. Any power that's other than those numbers that's positive, okay? So this would be 6 squared is going to be 6 times 6 for twice, right? 6 cubed is going to be 6 times 6 times 6, right? To the 4 times, okay? So we got to keep that in our head. Let's just cover it now. Negative exponents. Negative exponents, like 6 to the negative 2. You may remember what that means? OK. 6 to the negative 2 is actually 1 divided by 6 squared. OK. So any number to the negative of some other number, let's say a to the negative b, is equal to 1 divided by a to the b. Okay? Try this in your calculator. For those of you guys who have calculators, let's try that. 6 to the negative 2 should be equal to 1 divided by 36. Now here's how you have to do it on your calculators. Okay? There's a little button on most calculators that looks like a little a without the bar across it, a little caret symbol, we call that, okay? Sometimes you can type 6 and then that number and then the exponent, but you have to type the little, this is a good chance for me to say, so you can watch how I do it on this calculator. Your calculator may be slightly different. Let me do this. All right. Whenever I try to explain something and all of a sudden I have to use more words than I want, it's good chance to do this. OK. All right. Let's see. Where's this? OK. When this comes up, if you happen to have a calculator that's like the one that I gave you, or some other ones will do a very similar sort of thing, if you want to do 6 squared, let's pretend this is not the negative for now. 6 squared, OK? Do it right up here. 6 squared. You can do it a couple different ways on your calculator. Let's see. You could do 6, right? And then the little caret here, and then 2. Whoops. Of course, I did it. Let's see if I do this again. Whoops. Yeah. 6 caret 2. There we go. Enter. Gives you 36, which is what it is. Let me redo that for you. 6 with a caret and then 2. OK. Your caret key might look like this, y to the x, or x to the y, or something like that. OK? So if you want to do 6 cubed, you would say 6, the little caret, 3, and you get 216. Does anybody not be able to do that on their calculator? OK. Let's try this. What's 1 divided by 36? 1 divided by 36? 1 divided by 36 equals 0.02778. 7 keeps going on forever. OK. What is 6 caret? Ready for this one? See the little symbol down here? Looks like a negative symbol. Type that, and then type 2. And then type enter, and you should get 0.0277 repeating. Okay, Christine's looking at me like we're crazy.
No, I don't have a negative button, so I just had to put it.
You don't have a you don't have a negative button.
Yeah.
You may have a negative button on there somewhere, but it might take a special key press to do it.
Yeah.
We'll look at it after if you want. But anyway, this is all to prove to you that a to the negative b equals 1 divided by a to the b. OK? All right. Just wanted to show you that for now, because, and I ask you that because what does this number mean? 342.517. 3 means 3 times 10 to the 1, 2, actually. Here's how you do it. You look at this, you go 0, 1, 2. Start with 0 on this one. 3 times 10 to the 2, which is 310. Powers of 10 are easy, right? 10 to the 0 equals 1. 10 to the 1 equals 10. 10 to the 2 equals 100. Just add the number of zeros for the exponent. 10 to the 22 equals 1 with 22 zeros after it, right? OK? You do that? Anybody have science for 1 minute? Anybody know how many particles there are in the universe, roughly? 10 to the 10,000? Remember, the universe, you guys didn't take my science class. Universe. OK, so we've got our star, the sun, right? Our star is our solar system. And our solar system is in our galaxy. Our galaxy, kind of a big place. There's actually a billion stars. Sorry, 100 billion stars. I was off by 100. 100 billion stars in our galaxy. OK, but there's a couple galaxies. Any guesses at how many galaxies there are in the universe? 100 billion. OK? There's 100 billion galaxies with 100 billion stars. That's a lot. OK? So how many particles do you think there are in the universe? The net particles being like electrons, protons, neutrons, those kind of particles. Do you think you're right about this? 10 to the 10,000? What do you think? Way bigger? How many zeros do you think? A million zeros? Yeah, that would be a pretty big number. The answer is about 10 to the 76th. Here's the reason. Remember how I said exponents let you get numbers really, really, really big? That number is a huge, huge number. You don't realize how big 10 to the 76th is. Okay? It's as well, 100 billion stars and 100 billion galaxies, all the particles in those stars, right? And there's trillions of particles in every breath of air that you breathe, right? It's huge, huge number. Okay? It's a huge, huge number. Let me just bear with me for 1 second on this one, right? OK, what did I say? 100 billion stars in our galaxy, right? A billion is 10 to the what? Anybody know? A billion. 10 to the, what's 1,000? 1,000 is 10 to the third, right? So a million is 1,000 thousands, which is 10 to the 3. So that's a million has got to be 10 to the 6. A billion is 1,000 millions. So that's 10 to the 9th. OK? And that's a billion, right? Let's just talk about the number of stars. That's a billion. So we have 100 times that number, which is 10 to the 11th, actually, because you got 2 more zeros after that. That's how many stars are in our galaxy, times how many galaxies did I say? The same amount? Turns out when you do multiplication of numbers with exponents, anybody remember what you do to the exponents if you're multiplying them? Add them together. This would be 10 to the 22. That's how many stars there are, roughly, in the universe, the known universe, right? 10 to the 22 stars. OK? Think about how much, and that's a huge number. Think about how big 10 to the 76th is compared to that, right? It's like a huge, 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 huge number. So anyway, exponents let you get things really big or really small, as it turns out. OK. That was my digression into science for a minute. OK, this. So we said this means, well, by the way, if we go the other way, 10 to the negative 1 is 1 over 10, because we said it's 1 divided by whatever that is, number, right? 10 to the negative 2 is 1 over 100. 10 to the negative 3 is 1 over 1,000. OK? So this number still, this is 3 times 100 for this number, plus 4 times 10 for this one, plus 2 times, let me erase this, 2 times 1, which is 10 to the, I'll write it correctly, 10 to the 0, plus, now, the 5 is what? Plus 5 times 10 to the, what's the pattern here? 2, 1, 0, negative 1, plus 1 times 10 to the negative 2, plus 7 times 10 to the negative 3. OK? If you were to add all those up and do them on your calculator, blah, 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 you'd end up with 342.517. OK? That's what this number means. It is a rational number. How is it rational? Well, we can come up with a way to make an integer divided by an integer equal that number. We'll do that in a little bit. And by the way, that's one of the more advanced things we're going to do. And there probably won't be too many test questions about it, but we'll get there. OK, so there's your rational numbers as decimals. OK? All right. How do we actually figure out the decimal? Well, like I said, on your calculator, it's easy. You type the 2 numbers in. If I said 5 divided by 6, you would go 5 divided by 6, enter, and it would give you some answer. Let's do it out in this case. 5 divided by 6. If I was to do this longhand, I would go 5. 6 goes into 5 how many times? It doesn't. 0. We're not going to do the remainder thing right now. We're going to actually do this out like we used to do in grade school when we learned how to do this. OK, so if it's 0, OK, 0 times 6 is 0. 5 minus 0 is 5. Well, you add a little 0. Well, I guess you can add a little 0 here. OK, bring that down. 6 goes into 50 how many times? 50 divided by 6, let's see. 8, right? 48. So 8 8 times 6 is 48. OK, 50 minus 48 is 2. 6 doesn't go into that, so we bring down another 0. 6 goes into 20 how many times? 3. 3 times 6 is 18. Uh-oh, we're going to have to move it up here. 20 and 18 gives you 2. Oh, we got another 2. Looks like we might do this. 6 goes into 20 how many times? 3. 18. 6 times 3 is 18. 20 minus 18 is 2. Oh, we're going to do this forever if we keep going. 0.8333 dot, dot, dot. That means goes on forever. OK? So 5/6 is 0.83333. Your calculator would tell you that. OK? It normally rounds the last number. So in this case, it rounds down to 3, so 0.83333. If it was 0.86666666, it would round up to 7 on the last one. OK, but you can do this by hand. I don't really care that you do it by hand, to tell you the truth. The other one you're going to probably have to do by hand, but we'll get there. OK. Any questions on that? Do you want to do another example of those? Just divide. It's just division, really, right? OK. So, OK, decimal representations do one of two things. They either stop, OK? If you have, let's see, 1 divided by 2, right? 2 goes into 1. 2 goes into 1 0 times, put a decimal place, 0, 1, bring down a 0, and that 2 goes into 10 5 times. 5 times 2 is 10. No more remainder. We're done. There's a rational number with no repeating decimal after it. Okay? Or it repeats like before. Things like pi, no repeats. We're not going to worry about that yet. All right. OK. So let's see. If we want to represent numbers that don't repeat as fractions, it's pretty easy to do. 0.35 as a fraction is going to be what? Anybody know? Think percentages or whatever. 35 divided by how many zeros to get this over? How many decimal places are there? 1, 2. 10 to the 2 is 100. OK? 35 divided by 100. Do that on your calculator. What do you get? 0.35. OK, so we just converted that. That's an easy one. And you can do this with any that don't repeat. It's really easy. 0.352167. 1, 2, 3, 4, 5, 6. 10 to the 6th is a million. 352,167 divided by 1, 1, 2, 3, 4, 5, 6. We're done. OK, any questions on that? How to do that? OK, that's an easy one. You do have to be a little careful. Like if this was 352.167. 352.167. Now how are we going to do this? What's that? So what would you do? 352.167 divided by 10 to the 3rd, which is 1,000. Do that on your calculator. It would work, right? Boom, boom. You would get that. So you still only count the ones after the decimal place. Not too hard, right? If it doesn't repeat. OK. Now, we've done a whole bunch of stuff already that's been relatively straightforward. This is also straightforward, but I'm gonna teach you something that could blow your mind or not. I already blew your mind with the other stuff, hopefully, that like star stuff, right? OK. Let's say we have 0.444 repeating. We want to turn that into a rational number. Is it a rational number? It is because it repeats. Remember, that's one of the definitions of, well, one of the definitions of a rational number is that you can write, if it's a decimal, it will repeat. And what part is repeating here? The 4, and only the 4. OK. How many decimals, how many digits are repeating? This is how I'm going to want you to do this. How many decimals, how many digits are repeating? 1. 1. Put a circle around it because we're going to use that. OK. A little bit of algebra. Ready for this? Don't worry. If we have some number and we set it equal to 0.444, Okay? Let's multiply both of those things by 10. 10 times x equals what? What's 4.444 times 10? 4.444. Repeating. Okay? Now, you ready for this? This is the mind-blowing part. I'm going to rewrite this down here. X equals, whoops, 0.444. We should always put a 0 there. 0.444. Repeating. What happens if you subtract both of these things from each other? What's 10? What's 10 minus 1? 9, right? What's 10x minus x? 9x. Why is that the case? Because you've got 10 x's, whatever x means. You're subtracting 1 x away. You end up with 9 x's left. This is a little bit of abstract thinking we got to do here. What is 4.444 forever minus 0.444 forever? 4. You see how we now canceled out all those extra little 4s that were giving us problems before? All right. Now we have a little more algebra here. Here's what you can do with this. 9x, to get x by itself, you can divide both sides by 9. There's your answer. OK? Now, the 9's go away, and you end up with x equals 4/9. Somebody do that on their calculator. 4 divided by 9. 0.44444. OK. Let's do another example. Exactly like this one. This is one of those ones where you're going to have to practice this a little bit. OK? Because I just kind of threw a whole bunch of stuff at you. But once you learn how to do it, it's not too bad. OK. Somebody give me any other number that repeats with only one digit. 9. Oh, 9's a good one. This will blow you away. Blow you away. I'm going to blow you away. Ready? 999 repeating. You're going to say, I shouldn't have picked that one. 999 repeating. Ready? What did we do? We said x equals 0.999 repeating. OK? What did we do to both sides? Before we divided by 10, we multiplied by 10. 10x equals, what's this? 9.999 repeating. Then I moved this down here so we can subtract. 9x equals 0.9999 repeating. Oh, just won't do that. There we go. Now we subtract. What's 10 minus 9? 1. How many x's is it? 1. Oh, good. We don't have to do anything else. What's 9.9999? I'm sorry. Did I do this wrong?
Yes. 1x.
Sorry. Thank you very much. It is x. Thank you. 9x there. I lied. 10x minus 1x is 9x. Good. OK. What's 9.999 divided by, or minus 9.9999? 9. What happens when you divide both sides by 9? X equals 1. Guess what? No, you put it over. That's the answer. 0.9999 repeating is 1. It goes on forever, right? So you can't say it's less than 1 because it keeps on going forever. It actually equals 1. Yeah, I knew you. See, you shouldn't have done it. I shouldn't. It's too bad I screwed up in the math. But yeah, if you do 0.99999 forever, by definition, 1. It's a little weird, but it works out. Using this, it's tough to go backwards on this to get 0.999 repeating. It's a little weird, but that's the way it is. X equals 1. All right, so let's pick a different one. That one should just blow your mind. Let's pick a different one. Let's pick, I don't know, anybody else? 7. 0.7777. What do we do? Yeah, instead of writing it again, let's do it this way. X equals 0.777 repeating. OK? 10x equals what? 10x equals 7.777 repeating. 10x minus x equals 9x. You get the pattern here so far. 7.7777 minus 0.7777. 7. Divide both sides by 9. What's your answer? 7/9. OK, is that so hard? No, this isn't so bad. It gets a little trickier when we add one little step. But before we do that, let's do a slightly different number. Let's say that instead of 0.7777, let's do 0.787878 repeating. Sometimes we write that like this, 0.78 with a little bar over it, meaning those two numbers repeat. You could just do it like this, 0.78 bar, meaning it goes on 0.78, 0.78, 0.78. OK. All right. Yes, you're going to do that. I heard the result, means paying attention. If we do it this way, x equals 0.7878 ... We needed to get rid of the 0.7878 business. Last time we multiplied by 10. How many things are repeating now? 2. We're going to do 10 to the 2, which is how many? 100x. 100x equals what? 78.7878. Okay, oops, I was going to write it up here. Sorry. 100x equals 78.7878 ... Subtract. What's 100 minus 1? 99x equals, all that stuff goes away, 78. X equals 78 divided by 99. Type that in your calculator. Hopefully, you'll get 0.78787878. If you don't, math is wrong, which it isn't. It work? OK. So here's the trick. Whatever number, however many repeat, multiply by 10 raised to that number, and then do this little trick with the algebra to get it to work. OK? You guys can go home now and tell all your friends, we learned algebra tonight. And they'll be like, what, in one day? You'll say, yeah, we're that smart. OK. Let's try one more. Give me 3 digits. 7, 2, 8, repeating. X equals 0.728728 ... How many repeat? 3. 10 to the third is 1,000. 1,000x equals 728.728. Subtract 1,000 minus 1. 999x equals 728, because all the decimal parts go whoop away. X equals 728 divided by 999. Is that hard? No, it's a little bit tricky. I mean, next week, I won't do this. If I gave you a pop quiz next week and said, do it, you'd all go, oh my god, I forgot how to do it, right? Hopefully not. But you got to practice this if you're gonna remember how to do it. OK. Let me give you one more example. This stuff. OK, one more example, which is the exact same thing, but it looks a little different. And you got to do a little bit more math. I mean, a little bit more algebra. OK, let's say 0.412, and then give me one digit. 5. 5, 5, 5, 5, ... How many things repeat here? Just one number. See how it's not 4125, 4125, 4125? It's just this one. You got to look at the one that just repeats. If I wanted to, I could put the bar up there. 1. So what are we going to multiply by? 10. This is where it gets a little bit hairy. OK. X equals 0.412555 ... OK. 10x equals 4.2412. What did I do wrong? Oops, sorry. Yeah, thank you. 4.12555 ... OK, this is where a calculator is really handy on this. Okay, you could do it on paper or a board or whatever, but a calculator is really handy. What's 10 minus 1? 9x equals, what's 4.1255 divided by minus 4.12555? Well, guess what? The 5 parts go away, which is what you want. OK? But some of the other, well, not that one. OK? Somebody do this on their calculator. Forget about this part. Just do 4.12 minus 0.0412, let's see, 5. I guess you got to do a little bit more than that. You got to do until the 5 go away. So let's see, dot, 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 dot. You got to do at least that many, right? So what is it? 1, 3. OK. Now you have to do this. X equals 3.713 divided by 9. And there's your answer. Try this on your calculator. Do 3.713 divided by 9. Did we do it right? Is it this number? OK. So, but this isn't in a proper fraction because that's still a decimal. Yeah, you have to pad it with zeros. In other words, you have to do 1, 2, 3, multiply everything by another 1,000. So that times 1,000 is 3,713. 1, 2, 3. And then this times 1,000 is 9,000. That's the end answer. 3,173 divided by 9,000. OK, that was a pretty, that was kind of a little more than you might have wanted to worry about. But I just wanted to show it to you. There might be a couple on that sheet I handed you where you have to do this method, but otherwise, it's not too bad. Remember, however many digits repeat, that's what you're going to make the times the x to do this subtraction business. OK? All right. So let's see. Uh-oh, what happened there? Whoops. OK. Any questions on that? All right, good. OK. All right, a couple other things. So we're good with that. I'm not going to stress that too much more. Hopefully, you'll be able to do it for homework. If you have questions, let me know. Multiplying and dividing rational numbers. A divided by B times C divided by D equals something. Anybody remember how to do this? A times C divided by B times D. This is an easy one. If you're multiplying fractions, you multiply the tops together, you multiply the bottoms together, and you're almost done. You're done if there are no common denominators here, or common divisors here. OK? So an example would be 3/4 times 2/7. 6 divided by 28. Are we done yet? No, we got to do that. We got to divide by the common factor. If they're even, it's easy. Just divide by 2 and keep dividing by 2. 6 divided by 2, 3. 28 divided by 2, 14. If you tried to type this into your into the homework thing, it would probably tell you you're wrong. I would probably accept it on a test. I'm telling you that right now. If you don't reduce it, I'm not going to worry about it. OK? But that's the reduced one you're going to need for your homework. OK? All right. So far, so good. Let's see. 8/11 times 5/20. 8 times 5 is 40. 11 times 20. What's 20 times 10? 200 plus another 20. 220. 220. Are we done yet? No, you got to start dividing. The easy way on this one, what goes into both of those immediately? 10. Now what goes into there? 2. 2 goes into 4. 2 goes into 22. 11. OK. All right. Any questions on those? Good. All right. By the way, you might have to turn this into, not this one. You might have to turn some of these other ones into a proper fraction. In fact, let's do the improper fractions. This will annoy you, having to do this. 1 2/3 times 4 3/5. You're going to come back after doing the homework next week and you go, Chris, why did you give me those? Those were terrible. They're annoying. You can't just do these by looking at them like you might be able to otherwise. You have to convert these to their proper fractions first, right? 3 times 1 is 3 plus 2, 5/3 times 5 times 4, 20 plus 3, 23/5. 5 times 23 is 5. to 11, 115. Is that right? Yeah. And then 5 times 3 is 15, and then you got to reduce that, right? So let's see. 23 over 3 is actually what it is, I think. 23 over 3. 5 goes into 15, 20. Yeah, 23 thirds. Does that make sense? Yeah. Oh, well, here's an easy way to do this one, by the way. Do a little more algebra. Those two numbers, what's going to cancel out here? 5s are actually going to cancel out, as it turns out. Then you have 23 thirds. So that's an easy way to do it. If whoever said that and did that in your head, that was good. OK. Now, dividing rational numbers. This one's a little bit different. OK. Let's take an easy example. 1 divided by 1/4. Yeah, 1 divided by 1/4 is really just flipping. Anytime you do 1 divided by a fraction, you flip the fraction, right? 1 divided by 1/4 equals 4, as it turns out. OK? You can think of it in like quarters. 1 divided by a, well, that's not, I don't like that example. I don't like doing it that way. But the way we do this, and again, this is one of those things where when they teach you how to teach math, they ask you this question, and it blows your mind. Well, I never learned how to actually explain this, but the why about it. I'll show you the how. For instance, 1/2 divided by 2/3. Here's how you do this. OK? And I heard it earlier. Christine was saying this earlier. 1/2, what you do is you say times, and you flip the other side. 1/2 times 3/2 equals what? 3/4. OK? 3/4. Now, the question of why you flip it and why, when you divide 1/2 by 2/3, you get 3/4, don't get me started. Because I'm not sure I can actually tell you such that it makes sense, because I don't really get the mechanics of explaining why that's the case. OK? Maybe I'll have to look it up so I can tell you. But the point is, that's how you do it. So if you want to know how you do this, 1/2 divided by 2/3. You take 1/2, you flip over the second fraction, and then you multiply like you normally do. OK? Any questions on that? I'm sorry for leaving you without the why. I hate doing that. But you got to do that. If you're going to do improper fractions, same thing. You got to do that. You've got to turn them into proper fractions before you do it. OK? Let's do another quick example. Let's say 7/6 divided by 2/3. What do you do? 7/6 times 3/2. OK? And we could reduce this a little bit. We might as well just 21/12. How many times does 3 go into 21? 7. How many times does 3 go into 12? 4. There's your answer. OK. Got it how to do that? OK. The last one that we're going to talk about is how we add and subtract fractions. This one gets everybody the first couple times they try to remember it again. OK? When you add fractions, you need what? Common denominator. Thank you very much. OK? So any common denominators will do. So it doesn't have to be what we call the least common denominator. When you're in grade school, they teach you the least common denominator, days and days of that stuff. You don't need to do it. 1/7 plus 3/7. Can we do that? Yeah. What do? Add the top and keep the bottom the same. You wouldn't believe how many people get this wrong. What they do is they try to do it like they're doing multiplication. So they say, oh, this is going to be 4/14. And then what I do is I take a red pen and I go, no. Right? And I give you the wrong, I say it's wrong. Right? So you have to remember, that's not the way to do this. You have to keep the denominators the same. OK? And if they're not the same, you have to make them the same. And by making them the same, it can be easy as multiplying them together. That will give you a common denominator. And by common denominator, we mean the same number will go into both those numbers. OK? All right, so let's do another example here. Okay, let's see. Well, let's do subtraction. 2/5 minus 4/5. What's that going to be? Yeah, leave the denominator. If it's the same, we're good to go. 2 minus 4 is -2. So there's your answer, -2/5. Okay? And I think you could type it into the computer this way, or the negative and then the 2/5, or the negative, well, the 2 and then the -5 like that. I think you can. If you can't, sorry. OK? All right. Let's see. OK, ready for this one? Your first word problem of the course. One of the things is, somebody not like word problems? No? Oh, OK. Yeah. You know, I don't know why they screw people up so much. They're hard. I'm not gonna lie to you. They can be very hard, but you got to just pick out the parts that are important. Pick out the parts that are important. OK, you ready? You have 1/4. In other words, a quarter, like as in 1/4 of a dollar, and you have 3 dimes. OK? How much of a dollar do you have? 1/4 is a quarter plus 3 what? Tenths equals what? Well, what you have to do is you have to find this common denominator, right? We could find a common denominator, which is, we could find it like, let's see, 20 would work, right? But the easiest way to do it, multiply those together. You will have to reduce at the end, but we'll do it both ways. If it's 20, you have to turn this into a fraction with a 20 at the bottom, right? You can do that by multiplying the top and the bottom by 1. Why? Because what's any number divided by itself? 1. And any number divided by itself in 1, and 1 times any number is that number again. So you can do that. To get 20 on the bottom, what's 4 times what equals 20? 5. OK? So if we're multiplying by 5 divided by 5, what do we have to multiply the top by? 5. So this gives you 5/4 plus, well, 10 times what gives you 20? Yeah, what's that? Did I do it wrong? Sorry, thank you. 5/20, thank you. Got to keep me on my toes. 5/20. What's 10? How do you get 20 from 10? 2. So that's going to be also 20. 2 times 3 is 6. 11/20, right? Is your answer, right? Well, OK, how much of a dollar? Well, all right, this is kind of an interesting question. This is why it becomes a word problem. How do you get, what's out of a dollar? How many pennies? 100. How do you go from 20 to 100? 5 times 5. So 20 times 5 is 100. What's 11 times 5? 55. Whoa, we're going to have to start with that one next week or tomorrow. Because we'll have to start with a similar one anyway. OK, but anyway, the point is when you're doing addition, you have to find, and subtraction, you have to find a common denominator. And it doesn't have to be the least common denominator. OK? All right. I think we're going to leave it there because I can see you guys are like, oh my god, too much stuff. We'll see you guys tomorrow. If you have any questions, stick around. I'd be happy to answer them. And good first class. We are 1/16 of the way done with this course. All right.